Hi, this is Manish and I have my teammate Krishna Katragadda. We will be presenting our paper presentation with the topic A New Approach for Parallel Region Growing Algorithm in Image Segmentation using MATLAB on GPU Architecture. Let's introduce to image segmentation. Image is a two-dimensional distributions of small image points called as pixel. Image processing is a process of enhancing the image and extraction of meaningful information from an image. It will be partitioned into meaningful regions based on color, texture, depth, or motion. It is typically used to locate objects and boundaries in images. We may arouse many questions like what is the need of image segmentation when we can process the whole image at once? It is not a great idea to process the entire image at the same time, as there will be regions in the image which do not contain any information. For example, if you look at this first image, we have a dog which is covered with only like 30% of the image and the other 70% of the image is redundant. Whenever we need to process anything, there is no need to process this unwanted 70% of the data. When we divide it into segments, the dog will be separated and the background image will be separated, so it will be so cost efficient for doing image segmentation. Yeah. Why image segmentation when we can do object detection? Object detection builds a bounding box corresponding to each class in the image, but it tells us nothing about the shape of the object. We only get the set of bounding box coordinates. We want to get more information. This is too vague for our purposes. See here from an image, we can see that there are bounding boxes prepared from object detection. But when it comes to image segmentation, it creates a pixel-wise mask for each object in the image. This techniques gives us a far more granular understanding of the objects in the image. From the second image, an exact object is segmented, which gives us a better explanation. The goal of the segmentation is to simplify and change the representation of an image into something that is more meaningful and easier to analyze. Now let's come to segmentation techniques. There are many algorithms used in image segmentation, but region growing algorithm is one of the most effective technique and used widely. The same technique we'll be using throughout our paper. Next come to GPU, graphic processing unit. In order to achieve the parallel processing capability, generally we will accompany CPU with a GPU. GPU is a specialized hardware to show intensive graphics. Having multi-threaded capability, many core processor with high computational horsepower and very high memory bandwidth make GPUs the best option to achieve parallel computation. On the other hand, GPU performs quick math calculations and frees up the CPU to do other things, whereas a CPU uses a few cores focused on sequential serial processing. It has thousands of smaller cores made for multitasking. GPU actually improves the segmentation process by agile processing. CUDA. CUDA is a parallel computing platform which was developed by NVIDIA with their own GPUs. At the software level, the CUDA model is a collection of threads running in parallel. CUDA uses a shared memory model for carrying out communication among threads. CPU communicates to GPU through CUDA. CUDA provides an API through which we can make a call to GPU. That's how CUDA makes programmers to get the best out of GPUs for their general purpose computing. MATLAB. An image is a collection of pixels. For representation of images, computation and transforming them, these pixels will be represented in the form of matrices. Here, we will be using MATLAB for carrying out numerical computation. MATLAB also provides a way to work with parallel programs by integration through the programming model. Here, we take the help of CUDA programming model to attain this. The goal. We will be computing the performance of a serial and parallel region growing segmentation that takes the benefit of high parallel architecture of the GPU. Region growing algorithms for GPU will be presented in both serial and parallel implementation. The paper suggests parallel processing will improve the performance when compared to that of serial processing. Approach. The paper's main motive is to propose a different kind of parallelization scheme by using GPUs with high benefit from parallel architecture. We attain this by assigning each pixel to a distinct thread to process, assigning attributes to calculate spatial heterogeneity to maximize computational efficiency, using C and CUDA for implementing the algorithm.
Hi, this is Krishna. Now I'll be discussing about GPU architecture. As discussed already, normal CPUs cannot process high graphic and dense content rapidly. So when dealing with segmentation of dense images, it's better to go with GPUs along with the CPUs. GPUs will bolster the processing performance of CPUs. GPU architecture is the main reason for achieving this capability for GPU. Before going forward, let's get a basic understanding of a GPU architecture. GPUs nowadays are highly parallel, multi-threaded, and many core processors with high computational horsepower, with along with very high memory bandwidth. GPU with CUDA programming model provides an adequate API for non-graphic applications to interact with them. CPU sees a CUDA device as a many-core processor. If you look at the low level hardware architecture of GPU, CUDA enabled GPU is set of SMID stream processors. Each multiprocessor contains a fast shared memory, which is shared by all of its processors. Generally, a set of local 32-bit registers are available in GPUs. Some communicate through global and local memories with them. Shared memory is managed explicitly by programmers through CUDA. So if you see the working of GPU, the first step will be the data will be copied to memory of the GPU, and the parallel processing will be carried out. Then in the second step, GPU instructs the processing of CPU that this is the parallel work. Streaming multiprocessor execute the parallel code in each of its core using the threads. Then after the completion, the result is again copied to the main memory of the CPU. This is the fourth step. This Now we will go on with region growing algorithm. This is one of the implementation of segmentation techniques of images. This is an iterative algorithm. So in generally, as already said, the image is nothing but the collection of pixels. So uh, it's basically a collection of three colors: red, green, and blue. So in generally, the pixels will be represented in these three components, and the values will range from 0 to 255. But for computational purposes, we will be scaling this range to 0 to 1. So each image pixel representation will be scaled down from 0 to 255 to 0 to 1. So each pixel image will be having coordinates that range in between 0 to 1. And after that, the second step, we will calculate the region mean of the whole image. And the next step would be to find out whether two pixels are homogeneous or not. For doing this, we can calculate, we have so many methods to calculate on deciding the homogeneity of the pixels. So here now, to calculate the homogeneity between the pixels, there are many methods available to calculate the homogeneity. So the very popular method is in generally Euclidean distance calculated method. In this method, we will calculate the distance between the two pixels separated. If you see in the image, there is a pixel P1 and P2, and D is nothing but is the method of calculating the distance between these two pixels. So the decision of deciding whether the two pixels belong to same segment, or the decision of making the two pixel homogeneous will be decided by taking threshold value. This threshold value will be an input parameter that will be given by the programmer. So basing upon this threshold value, we will make a decision whether two pixels are homogeneous or not. So if you go to the next slide, see this is the condition of deciding whether pixels are homogeneous or not. We will apply a method for calculating the distance between two pixels represented in three-dimensional space. If the distance between those pixels is less than or equal to the threshold given by the programmer, then we will make a call or that these pixels are homogeneous. If the distance exceeds the threshold value limit, then we will consider these pixels to be homogeneous. The reason for doing is this: the assumption that the pixels that are nearby will be having same properties. If you consider an image of a dog, so any two pixel any two pixels that are present on the image of a dog are assumed to be having same properties. As they will be in same close proximity, they will be considered as homogeneous. So we will do the same process and repeat the whole process for each pixel that is present in the image. So this process is carried out iteratively, and we will stop when all the pixels in the images are segregated into segments of basic upon the homogeneity condition. So this is the basic region growing algorithm, and which till now we have explained the region growing algorithm in a serial manner. Now we will have a look at the parallel implementation of the same region growing algorithm. See, the main difference comes when the implementation of region growing algorithm parallel is in parallel algorithm, we will assign the iterative looping part that were present in serial code to multiple number of threads that work independently. We are having the luxury of having multiple number of threads here because we are using GPU architecture. So for attaining the parallel processing power, we are taking help of GPUs, and we CUDA programming model which will be implemented on GPUs, and we are also taking help of MATLAB. So before going for parallel implementation, we have to set up the environment with all these three components integrated with each other. And now we will go through the parallel implementation. As mentioned earlier, similar to serial implementation, we will convert the image range from 0 to 255 to 0 to 1. Now the actual implementation of parallel algorithm starts. First, the CPU makes a call to GPU through API, which is provided by CUDA programming model. And after making a call to GPU kernel, then it will send input parameters such as number of blocks that has to be created, number of threads that are to be created to perform the task, and the dynamic memory that has to be associated per each block will be decided. Along with all these input parameters, the threshold value for making the homogeneity decision will also be given to the GPU. Once these values are assigned, the region mean of the whole image will be calculated again. After that, inside kernel GPU kernel function, we will create two shared variables. One variable to store the region mean, and the another variable to store the intensity of pixel point parameters for global memory. And we will start calculating the difference between this intensity value and the region mean. If the difference between intensity value of the pixel and the region mean is less than the threshold value, we will choose that neighbors for merging by writing the result into shared memory. Finally, we will get a list of different pixels that are candidate for forming a separate region. This process stops until the difference between the pixel intensity and the region mean is less than that of the threshold value. And finally, the result will be written into the global memory of CPU. Once the whole process is done, we will try to depict two images of the image before segmentation and after segmentation, and for this purpose we will be using MATLAB. If you see the performance analysis in this experiment, we have an MRI brain image is taken and it is used for segmentation. And on this, both parallel and serial implementation is done. If you see, these are the results that came when region growing algorithm is applied on serial and parallel, and the both the results are compared against each other. If you see in the graph, we can clearly see that when you use CPU, just a serial implementation, that means when we have taken decision only on the CPU processing power, we can see the time that was required to take up the image segmentation task is quite high. But when we have taken parallel implementation, that means when we have taken CPU along with GPUs, the time needed for execution is quite low. This is a significant improvement when it comes to segmentation processes.
Let me conclude with the summary of our presentation. We have gone through the process of image segmentation and the various algorithms for doing this. Our motive is to attain high computational speed and high performance at a low cost. For that, GPU based technology will be the future in the area of image processing and segmentation. The parallel algorithm essentially assigns a particular thread to each image pixel so as to exploit the GPU support of fine grained threads and a large number of processing elements available. It should also be noted that these performance gains can be obtained with low investment in hardware, as GPUs with increasing processing power are currently available on the market at declining process. We can further optimize our result using a new version of NVIDIA graphic card by selecting automatic seed points rather than doing that manual. Thank you.